Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, May 26th, 2026. Tonight, we will do our normal presentation of robotic projects and then open the floor up for questions or discussions. Just a few housekeeping items. Roboama 2026, Dallas Personal Robotics Group hosted Roboama at the Dallas Makerspace last Saturday. It was well attended with many participants, and that I remember it was Quick Trip, Mini Sumo, and 6Can. Am I missing any of the events that were held?
Oh yeah, you got barrel racing, four corners.
Barrel racing, four corners were held as well. Did anyone do the line following?
No, we didn't have any line followers, so we skipped that one.
Okay, so it was very well attended. There was several participants and robots, and it went really well.
Yep.
So if you didn't catch it, check it out on the video. It's posted on the DPRG list or in Discord or Facebook. This coming Saturday, Texas Robot Combat will be holding a robot rodeo. It'll take place Saturday, May 30th. Events include fighting open ants, plastic ants, open beetles, and it's free for all ages of the public. Fights start at 10:30 a.m. Be there early for best seating, and it's hosted by Rev Robotics in Carrollton, Texas. And the next one is Moon Day 2026. It'll take place on July 18th at the Frontiers of Flight Museum. DPRG is looking for volunteers to attend and show off robotic projects. So that is it for meeting business. First up, we have Tom.
All right, I'm just going to share a screen here. Incidentally, I touted the monthly meeting contest at the Sunday Ottawa and Vancouver meeting to encourage them all to look at it on YouTube. They were quite impressed. Many of them still haven't heard about things like that, so it was kind of fun.
Oh, cool, thanks.
Well, thanks for mentioning that, Tom.
Okay, let's share this. I assume you can see the mouse. You can see the picture of the mouse. Okay, I think I've mentioned in the past that I am working on a larger outdoor robot chassis to experiment with autonomously, having built one that ran well in my backyard, but only on nice manicured lawns, doesn't run well in the park. So this is the beginnings of a larger one. You can see the wheels are 8 inches. The platform's much larger, and it uses a much more powerful gear motor. These are salvaged vintage screwdriver gear motors. I have a couple of them that are virtually identical. This wooden platform holds the gear motor and a timing belt pulley and an encoder wheel with some quadrature encoders. And this is what I've been working on so far. Here's another view of it. Gives you a little better feeling for what's happening. This is a differential drive experiment. We'll see how well this works. It's got a 5-inch dolly wheel sitting underneath here, made from an old office chair caster with a much bigger wheel on it, a 5-inch wheel. And these are 8-inch tires off of a kid's ride-em toy. I didn't have enough motors off the kid's ride-em toy. It only comes with one. So I had to come up with something else. Now, the fun part is I had originally attempted to coaxially mount the wheels on the end of the gear motor shaft, the place where you'd normally plug in the little hexagonal screwdriver tips. But it was very wobbly, and I didn't see any practical way to improve that. So rather than take the nice straightforward direct drive coaxial method, I now have the tires mounted back on the original 3/8-inch solid steel shaft that they ride on when a kid rides on this thing, which meant I couldn't direct drive them, hence the need for implementing a timing belt drive so I can offset the gear motor from the drive of the wheel. That looked like an obvious thing. Everybody's played around with timing belts on CNC machines and 3D printers, for example. I got some advice from one of the guys in Ottawa on where to get nice, cheap timing belts. These are 5mm timing belts. This is a 430mm loop. I bought them off AliExpress. They're less than a couple of dollars each. So I bought a handful. That worked out well. And I had found some Thingiverse scripts that allow me to produce parameterized pulley wheels. So I produced a couple to see what would happen. First, let me show you a couple more details of the gear motor. The gear motor, the 3D printed mount that holds a couple of transmissive IR sensors. Each of the IR sensors is mounted on its own small circuit board. The circuit board's mounted with screws onto the 3D printed mounting plate, which allows me to adjust the IR sensors individually in order to be able to get the correct spacing for a reasonable quadrature signal as identified on my scope. The 3D printed pulley doesn't look like any big deal. We'll talk about that some more in a minute. There's one twice the size, which is screwed onto the inside of the wheel down here. You can just see the timing belt sitting on top of it down below in the bottom of this picture. Another closer look at the IR sensors. This is a 3D printed 32-hole encoder wheel. In separate testing, this stuff is working very, very well. I'm quite impressed with it. It wasn't very hard to put together or set up at all. So we'll proceed with that some more and see if I can get half-decent quadrature encoded signals off of it. Now, here comes the fun part. Whoops, sorry, we're going way too fast here. I'm giving away the secrets. So the fun part was I'm getting really crappy fit, and I'm getting a lot of wow. I'm getting a lot of mucking about. Let me just back up one second. Oh, this way. You'll see over here in the corner, there's a spring which I mounted to allow some dynamic tensioning of the platform that the gear motor sits on, knowing that that's probably a good thing to have when you're running with a belt. The wooden block that the gear motor is mounted on is pivoted back here, and the spring over here simply allows me to place tension on the belt. I got all this stuff up and running, and I'm getting really, really bad experiences with this thing. I can see this plate that the motor's on is moving several millimeters back and forth as the belt turns, and I can see the belt kind of creeping up around the edges of the pulley. It's just not looking good at all. So after playing around with a couple of different pulley printouts, I cut the end flange off one of the pulleys to get a feeling for what it looks like. So this is what the pulley looks like after it's 3D printed. Incidentally, the design for the pulleys and their mounts is a script that runs in OpenSCAD and is surprisingly easy to use and seems to work very, very well. I was quite happy with how all that turned out. But that's what the actual pulley looks like when you cut the flange off the end. And when you put a belt on it, it looked like this. This is not good.
Oh, wow.
Pardon?
Wow. Okay. Yeah.
The teeth on the belt fit here. The teeth on the belt don't fit up here. Like, what on earth is wrong? Is this just a crappy script in OpenSCAD, or is there something else I've missed? So
that's a crappy printer.
No, it's not.
That is a crappy printer.
Nonetheless,
that is definitely a crappy printer. You can look at it and see.
So what I did was I decided to start doing some searches. I'm looking for folks who have discussed any issues with producing 3D printed timing belt pulleys or with the use of the OpenSCAD script, which turns out to be pretty much the most popular script to use to print pulleys of several different types. So it turns out that when you Google questions like this, hoping to find some discussions in forums, these days what Google gives you first is its own AI-based opinion. That turned out to be quite useful. So I did several rounds of discussion with the AI Gemini tool once I discovered that I could converse with it. And I've summarized a little bit of what it told me as I started asking questions. Number one, it said, have you got the right profile for the timing belt? I said, well, duh, it's a timing belt, right? How hard can this be? Well, it turns out really hard.
There's tons of different profiles.
Yes, I had no idea. So that alone was worth the time I spent messing around. I just assumed I had a timing belt, and I thought that T5 stood for timing belt or teeth.
No.
Turns out it stands for something completely different, and it's not what I own. Turns out what I bought, you won't be able to see them here, but what I bought was HTD 5M belts. So a completely different profile. An elliptical.
That's a very common profile.
Yes.
And it is fully printable. In fact, it's even kind of a coarse profile. Yeah, so it's actually easily accomplished if your print settings are right and your printer is good.
Well, I'll skip to the end first since you brought it up already. Where is it? Darn it! Don't tell me I didn't include it.
You can just tell by looking at that. Although some of that is bandsaw warping.
What, this thing?
But your cut through there. That's just horrible looking teeth. Horrible looking.
And that's because I cut it off with a hacksaw.
Okay. All right. Yeah, that would warp it a bit.
Yeah.
But that's not the only thing going on in that profile.
Anyway, I thought I had included a picture of one of the test rings. Once I implemented recommendation 1 and recommendation 3. 2 I wasn't worried about. 2 says make sure your printer is doing a good enough job, an accurate enough job. Number 1 says use the right profile. Number 3 says use a little bit of slack space between the flanges when you print the pulley, which I had not done. I had made it tight. I've got 10 millimeter wide belts, and I printed the pulley 10 millimeters wide. That's not a good idea.
Oh yeah,
that's not a good idea either. So I did 1 and 3, and unfortunately I didn't include in this set of prints the result of implementing that was easy to see. It was a cutoff test ring. But what I've got here is one of the final pulleys with the belt wrapped around it, and you can tell from this image, these flanges are only 2 meters high or 2 millimeters high. So you can tell the belt is sitting in here very, very nicely. I assembled all this stuff together this afternoon and got it working, and it works so much better now. But I kept thinking, Jesus, if I'd only done a few things differently, like paid attention to the numbers on the belts I bought, for example. Anyway, the final outcome is the script I'm using in OpenSCAD to produce the parameterized pulley works really, really well. As far as I'm concerned, I'm getting very nice running of the timing belt on the pulleys I'm now producing. And I'm pretty happy with the way this has turned out. So I've got one side put together and running, and I will put together the second half, add some sound control, and we'll see where it goes from here. Any questions?
I'll just say that 2 millimeter pitch is kind of difficult. You really got to tune your printer beautifully, and you probably want a smaller than 0.4 millimeter nozzle for that. That gets tricky. 3 millimeters is easier, and 5 millimeters is quite doable on most fairly good 3D printers.
Okay. When I started to ask more questions, I got into domains of 3D printing that I'm not familiar with, and I referred to them a little bit at the bottom of this list. For example, they talked about the choice of wall generator. Well, I don't know anything about wall generators in my 3D printing slicer, and I started to Google it a little bit to the slicer I use, and didn't learn anything. So I don't know what that means yet.
Yeah, you can select the number of walls that you print before infill starts.
They talked about using an Arachne or a classic wall generator. I couldn't find references to those that made sense. Maybe it was hallucinating.
There are different algorithms that different slicers will use. So, but it's very specific to your slicer.
Yeah, that's right. And I'm not about to change the slicer because I experimented with 3 different slicers when I first got my machine 10 years ago, and realized that they're so different that I would end up fine-tuning each one individually. So I picked the one recommended by the supplier of my 3D printer, and I stuck with it. I worked at getting that running well. I stuck with it, and I have.
Well, splicers have come a long way, baby.
Yeah. Well, I'm running updates as of a few years ago, so if there's an update, I've got it. I just use the same brand, something called Slice 3R.
Right.
I understand
Backwards it's a backwards 3, so it's slicer, but yeah.
I understand that a couple of the major 3D printer companies use variants of Slice 3R. So I guess it's a good one. It's always done what I wanted it to do without any concerns.
Yeah, I usually print the outer wall first. Does anyone have any idea why you would print
and
it
that's what
last?
they recommended, but I couldn't find any reference to wall generators in my slicer.
Oh, like
which one are you using?
Curie.
Curie, okay. Cura,
probably.
Yeah.
Okay.
Anyway, I normally print the outer walls first, and I couldn't figure out why you'd ever print the walls last.
and the explanation that Gemini gave me made sense. They basically said the same thing, because if you print the inner ones first, then the outer ones get pushed out away from where they're supposed to be. I don't know. Anyway, it's working. I'm really happy. Finally.
Yeah,
I'd share that. Number one is
great.
Know the parts you're using.
Yeah, if
I learned a lot about timing belts.
If Slicer doesn't have the settings, then look at Prusa Slicer, because that was branched off of Slicer and it has more settings. So check out Prusa Slicer.
Okay.
And then Bamboo is branched off of Prusa. So, but Prusa's good.
Okay.
It's free.
So anyway, that's my story for the evening.
Thanks for sharing, Tom.
The last of the pulleys is printing on my 3D printer behind me.
Yeah, so I guess on outdoor you could have your wheels slip, because it seems like you might have some slippage on those belts and your encoders on the motor. So
I don't think the belts will slip. I'm using cheap toy tires. They'll probably slip.
Oh, that's probably yeah, they'll slip.
The whole reason for using timing belts is so they won't slip.
Yeah. Right. Yeah. They'll slip.
Oh yeah, but they can still slip. You still got to manage the tension on them.
They might jump, and that's why I've actually identified several locations in advance so I can change the tension on the spring that's applied to the belt. I don't know how much tension I should put on them. Not a whole lot, but we'll see what happens in use.
Yeah. So your tires, your wheels were hard rubber or hard plastic.
Yep.
So they're gonna slip more than the belt. Yeah.
But it's an experiment.
Yeah.
I may cut up an old inner tube and wrap it around the tire.
There you go.
Yeah, one of the I don't know if he was considered one of the founding members, but he used to cut up bicycle inner tubes and use them for tires around plastic, 3D printed wheels or metal wheels. So it seemed to work pretty good. It looked pretty good.
By now, I tend to keep a lot of stuff, so I know I have some old bicycle inner tubes and over on my other workbench.
Yep.
Yeah, but you might want to use the bicycle tires because you really want the treads to maintain traction. Yeah,
that's a good point, Mike. I wonder if I could get those on those wheels.
Hot glue. Yeah. A little bit of hot glue and
maybe, yeah.
A lot of hot glue.
Hot glue might work in Canada, but not Texas. So, yeah.
Yeah, it'll either melt in the summer sun or freeze and crack in the winter weather.
It works fine in Vancouver. Very mild there year round.
In my spare time while I was waiting for printing, I was looking at switching from PLA to PETG. And I noticed that everything runs a lot hotter when you print in PETG.
Oh, yeah. Yeah.
I've been having some good luck printing with PETG lately. I've never used it before, and with I got a Bamboo Labs printer, and it's just turn it on and let it go. So the biggest thing I found is make sure your filament is dry.
Ah, okay.
So if it's not dry, then it won't stick to the plate, and it heals up between layers. And
wow. Do you print right out of a dehydrator?
No, I leave it. I throw it in if I'm going to print. I throw it in for a few hours before, and then load it into the printer. And I'm good usually for a day or so before it gets too humid and starts to give me problems.
Okay. As you can see, my layout behind me, the coil of filament just sits on a rod above the printer.
Mm-hmm.
We usually print nylon, and there are times when we intentionally get it wet, damp it, in order to improve interlayer adhesion.
Okay.
It makes a really ugly print, but it's tough as nails.
So you get a little bit of blowout as it's extruding, and that binds together between the layers.
Yeah. Yep.
Interesting.
I was surprised because PLA, I've never had any problem. I've never had to put it in a dryer. I just throw it in the printer and if it works. And with the PTG, I was running into problems where it's not sticking to the plate. I'm washing the plate. I'm trying to, make sure the nozzle is not plugged and whatever else, and it's just driving me nuts. And I turn around and I threw it in the dryer, and next thing you know, it's working fine again. It's sticking to the plate. Everything is good. I would like to get into printing with some other stuff, so TPU and whatever else, but I'm not going to brave it. Not yet. And I haven't tried anything as complex as a pulley.
Well, it's turned out well. I'm pretty happy with the outcomes so far.
Yeah, your end product looked to fit well. I'll be curious to see how it runs.
Yep. Well, my first trials this afternoon on my motor tester, it was running okay. It's not like with aluminum pulleys, but it's still almost good. It's still good enough. So
That's good. Does anyone else have something they'd like to share today?
Yeah, if you have questions about my platform, I can try to answer them if you want.
That would be great, Ray. Can you maybe give us a little bit of a talk about your strategy and how it went on the weekend?
Went pretty good.
The run was very impressive.
Yeah, it's I think there was a little bit of demo mode going on. The first of 3 runs was good. The second 2 were not so good. But the first run was good. Actually, when I put it down to demonstrate it before the contest, it was working great. So I kind of suspect that it was seeing the cans on that side of the course, and that's why it was stopping short of the goal. It wasn't dragging the cans all the way in, but kind of ran out of steam with the older platform. The motors were pretty much maxed out, couldn't go much faster. It's time competition, so if you can get 6 cans in the goal at least amount of time, you're the winner. So there were other things that were making the older platform slower too. I used to have one of the TF minis on a servo, and I'd actually scan to look for the goal and look for big differences in readings as it's scanned on the board side of the goal and then the opening side, and I'd look for 2 big changes, increasing and decreasing, and just try to find the middle of that. And that's what I was using to find the goal. But you're kind of it's, and then after I decided where the goal was, I would rotate a certain amount. So it was kind of like a point and shoot approach, and it worked okay. It was just that I couldn't get any more speed out of it. So one of the things I thought about doing was what Scott did, put bigger wheels on another platform. And so this was actually the platform that I was playing with. I never ran it in a contest, but did have much bigger wheels, much, higher RPM motors. But kind of also had the Mecanum wheeled platform and wanted to play around with that. It's Carl, oops, caught on the rug. Carl had the same platform and it looked kind of neat. So at one point, probably about a year ago, I bought one and played around with it a little bit, and then, kind of played around with other things. Anyway, drug it out and really wanted to use it because close to the goal that you're supposed to put the cans in, you get caught around the corner of the goal. So you really have to move like more towards the center of the goal and then go through the goal. Otherwise you can hit the corners of the goal as you're trying to drop the can off. And one of the nice things about the Mecanum wheel platform is you can strafe sideways. You can not just go back and forth and other angles, but completely sideways. So my strategy was to find the center of the course. It's like 100 and, if you round up, 107 centimeters, I think it's like 106.68 or something like that. Anyway, if I could get to the center of the course by looking at the long wall to the right, I should be able to follow that wall or keep that distance, and that would get me through the center of the goal. And so that's what I did, and it worked very well near the goal because I could move sideways to the center of the course and then just drive through the goal. So so after that, it was just trying to get as much speed as I possibly could. There are two distance sensors. They're the ones that output a pulse width modulated pulse that's proportional to the distance. So one faced right, one faced forward. The one that faced forward, I used that to sense how far away the can was to the platform, because I could run at high speed, but I couldn't grab the can at high speed. I had to slow down, because if you don't slow down, you ending up, bumping it, knocking it over, and then it's really hard to get the can. So I had to basically look for a distance of 15 centimeters before and then I would slow down to a slower speed that wouldn't knock the can over. And I could actually pick it up with the gripper and then move to the center. The other thing, I forgot, should have probably mentioned that in the beginning. It also has a B&O 085, and I'm using that just for yaw. So more or less like a compass. So when I turn the thing on, it takes an initial reading. So I have to be lined up on the course, so parallel with the long walls of the course. And every time it tries to move back to the center, it's reading what the compass value is, because you don't want it to skew or rotate. So you want it to maintain that initial heading or initial reading. It should be, parallel to the long walls of the course. So what I would do is, after I grab the can, I would rotate to that initial reading wherever it was on the course, move to the center, and then move forward. So, and I also tried, you can do, it's kind of like up and to the right, back into the left, and up and to the left and back into the right, kind of movements with Mecanum wheels. And I also kind of experimented with just using that motion. So it's not a left-right strafing motion. It's kind of a, you know, diagonal motion basically, and that works except right near the goal. And so I pretty much went back to finding the center of the course, and then, you know, trying to shoot through the goal that way as fast as I could. So some definite advantages with Mecanum wheels. Oh, and the camera that I used on the front was basically blob detection. It's one of the Max Cams, MAIXCAM, and those that worked really well. It comes with see if I got one open here. Comes with a little LCD on the back. You can connect to it through Wi-Fi, so you can actually see what you know, what the camera's looking at, and you can, you know, display images on the LCD touchscreen on the back. So I don't know, they're pretty reasonably priced. You can do, you know, create. You know, you can take like 500 pictures of some object like a can or a cone, and use AI to make a, you know, to make a model, download the model. I think it supports up to YOLO 11 now. But for the indoor contest, it's, you know, it's just doing blob detection. So it does that pretty good. The other thing that I did, you'll get several blobs that it sees out there because there's 6 cans. I tried to get the blob with the largest pixel, or largest number of pixels in the blob, and that should have been the closest one. So then that way, you know, I don't try to go after multiple cans, or start out with one, and then depending on the orientation of the robot, that one could appear to be the larger one, and then it would shift off to that kind of prevents that. So
So you didn't try to clear the cans that were obstructing the goal first?
yeah. So if there's any right down the center, you know, it would try to go for that one, and in a lot of cases that one appears as the closest one anyway. So yeah, so the kind of the strategy was to come out of the goal, and I actually come out of the goal at different distances to get the cans that are further back, because you know, depending on the lighting, the blob can be smaller because it's not seeing all the colors that, you know, that the camera's seeing at the time. So it actually comes out and tries to clear it, you know, center first, and then to the left, and then it moves around clockwise to try to clear out the rest of the cans. So it comes out of the goal after it drops off the can, different distances, and rotates at different angles at a higher speed than it looks at, or when it, yeah, a higher speed than the speed that's used to look for the can. Because if I rotate too quickly, it doesn't see the, you know, it just bypasses the can. It just doesn't see it. So the you know, the speed that you rotate at can't be too fast because you'll miss the cans. You can't grab the can moving too fast because you'll knock it over. So those speeds are kind of maxed out.
Did you,
so
did you try to avoid cans when you already had one?
Say that again.
Did you try to avoid cans in front of the goal when you already had one in your claw?
Oh no, yeah, that was the other thing. The way the camera was mounted, when it has a can, that's all it sees is the can.
It's blind. All right. Yeah.
So I don't have to, well, yeah, in that case, if it has a can, it's not looking for another can. So it drops it off, and I don't look at the camera until I've backed up and, whatever amount I'm backing up and it rotated whatever angle, I'm rotating to. Then it actually starts to look for the can. So that was kind of nice. I didn't have to clear the goal of the cans. So yeah, so it worked out. So
Did you use Ross?
No. Did I use Ross? No, this is an 8-bit Atmega 256, processor. No Ross required. So,
So Ray, what was your fastest time?
you'd have to ask Mark. I thought it was, I don't know, somewhere between 1 minute and 10 seconds and 1 minute and 15 seconds.
It was
Yeah,
faster.
I thought he mentioned 1 minute 50 seconds, and I thought that was a course record.
It was faster than Scott.
Yeah.
So that's congratulations if that's a course record.
It was 1 minute 13 and 68.
Oh, okay. 1 minute 13. Okay, good. Yeah, I didn't know exactly what it was, but and
that's even with missing, not putting one all the way out. Like,
say that again.
yeah. I think the first run you didn't put, what was it, the first run? Or was it the second 2 runs? I know one of the runs it didn't take the can all the way out, and then it just went back and got it again. So it kind of did 7 cans more than 6 cans, but
Yeah.
yeah.
Anyway, so a little self promotion here. I made myself my own 6-can little trophy here. So
Yeah, old can man killer.
say that again.
Old can man killer.
Yep. So the and it, you can have different inserts in it. Like, so here's another one of kind of 2 humanoid figures, one kicking the butt of the other one. So, I can have lots of fun with this. So, but creating different inserts and
Well, I want you to know that after 1 minute and 13 seconds, Ray, I just grabbed my robot and I threw it in the garbage.
No, don't do that. So,
That's a very tough act to follow.
that's I'm kind of hoping if I can't win the next one, that somebody else will, that other than Scott. So but
I remember reading about an article in a magazine about a 6-can competition or a can competition years ago in the 90s. And it was 2 minutes to find a can, and it was 32 minutes, I believe, to clear the field.
Oh my God. Yeah.
So that was I think it was the late 90s.
That sounds like my robot. Yeah.
Yours is a lot faster than that, Mike. I think yours does what, 1 can a minute or so.
Anyway, took about 5 months to develop. It's I think around 1,000 lines of code. I try to use AI, kind of as a springboard for ideas. Like, I'd say, okay, I'm thinking of doing this. Does it make sense? And it'd give me its 2 cents on whether it thought that was a good strategy or not, or I'd ask, how can I optimize this code? And, I'd give it, a little snippet of code to say, okay. And it would, some of the suggestions were good. But, I think it's pretty much maxed out as far as speed goes. The distance sensors, they'll cycle between 30 and 33 or so milliseconds, and they're interrupt driven. So there's 2 of those. There's 4 quadrature encoders for the 4 motors, and that's interrupt driven. So I don't, you know, I'd have to do kind of a detailed timing analysis to figure out if, you know, if I go any faster, am I overrunning the sensors or not getting enough updates for whatever distance I move, kind of thing. So, but so I think at this point, and I one of the other things I found out, I was using an OLED display, and it's a 128 by 128 OLED, and I noticed, you know, just to kind of throw out a bunch of variables to see if I could see what was going on, and that actually slowed things down. It was interfering with loop timing. And once I got rid of all that, I could go to a TFT. You know, TFTs with a SPI interface are much faster than even a 400 kilohertz I2C OLED. So anyway, so I might do that just to get some a little bit more debug information out of it. So I could also maybe add an ESP32 and use ESP now to, you know, transmit a bunch of variables, you know, relatively quickly and that kind of stuff. So, or do kind of like you have ROS bags, you know, throw a bunch of data into an SD card and, you know, take a look at the SD card afterwards and plot things out and see what, you know, see what it shows me. But otherwise, yeah, I guess an 8-bit microcomputer doesn't really lend itself to, you know, very easy debug. So, but it's kind of like make changes in the code, try it, see if it works, you know. But anyway, yep.
And it worked. Yeah.
It worked.
Yeah.
Yeah, I think Scott was sandbagging his time there. He said, "Goes, yeah, I think I'm at 2 minutes," and you know, I think he was telling me that to, you know, if I could just beat 2 minutes, like, you know, a minute 45, you know, then I'd you know, I'd be in the winning, or in the running rather, and but I knew his time was like a minute 30, so I was like, nah, I'm going for, you know, less than a minute 30 if I can get it. So, but and it kind of depends on where you put the cans too. You know, some of the can layouts are much quicker to, you know, the runtime is going to be a lot shorter than other ones where, you know, you've got cans all over the place and, you know, front corners, back corners, that kind of thing. So anyway,
Good job, Ray.
thank you. So that's pretty, you know, all I had.
Mike, are you ready to
Yes.
talk about your platform?
Well, I'll just talk about my barrel racing because that was my newest entry into the race, the barrel race, and I was assuming that when people just mapped it out and didn't use sensors, they just used just raw odometry to go around based on known locations, that they would run faster or more accurately and stuff. So I was really pleased that I was using sensors to detect the cans and go around them, and I did a better job than the odometry based ones were doing. So I was surprised at that. Like when I used my LiDAR, because the LiDARs can see to the side, and so and the front and everything. So when I'm approaching a can, I say, okay, I want to be to the side. So when it's at the side of the can, then you know that the LiDAR sees the can 90 degrees relative to the robot, and you know the distance. And so those are the two variables I was using in my feedback loop, is is the angle from the can to the robot and the distance. And so when I was approaching a can, after I located it with a camera, then I started using the LiDAR to just make it, I can't remember what it was, like 10 centimeters away or something, and 90 degrees, and it would just maintain that distance and angle when it went all the way around the can, and then when it went like 300 or 180 degrees, it would break out and go to the next can. So I would track the angle and break out and say, okay, stop. Don't go. Otherwise, they keep going around the can. So I was really happy because that gave me first prize, and it's the first one I did. But I spent a lot of time on it and didn't have time to improve the 6-can. So basically the 6-can worked about the same as last year, even though I changed the sensors out a little bit. But yesterday I had this other art project going on, which is a sculpture, and I've been helping build a sculpture and the rotating platform and stuff. And so yesterday was a photo shoot for media, because in 3 weeks we open it up at the gallery, and so we got to get some media out there to get people to come see it. And so we put, everything's not ready, but we had a good prototype running and everything. And then a couple months ago, they were saying the guy that's doing the videos and everything is going, oh, we're just going to have timed loops. Like the videos are going to be timed, because basically the sculpture rotates and the video changes based on how it's pointing. And so it says this is going to be timed with, basically stopwatches, the counters, the timers and stuff. And so I pulled out some of the code that I used for remote control. And then he says, oh, we really need a remote control. Like when the video starts, I want you to, start the rotation at that moment. And so today I was working on that, and I have it running. Maybe I can show it. I'm gonna grab my camera or my whole thing and go downstairs and show you the statue's not there on it, the sculpture. So I'm just making sure that it repeatedly goes to the right location. And I have limit switches on the bottom to make sure it goes in the right location. So this is the so that's the rotating really fast. We're gonna have it rotate slow for the exhibition. And it'll rotate for a minute and then stop for about 4 or 5 minutes and then rotate again. And so what I have is I'll bring up the code, the control code.
Are you showing something?
Yeah,
Oh,
you're showing the table turning.
It's just on the table.
It's weird. I'm not seeing him.
Well, it's just my video.
His video is pinned.
Okay, I think Ray's just having phone issues.
Okay. Yeah. And so now I got one computer looking at another computer here. And so there's something used for performances, theater, stuff like that, and that's QLab on a Mac. And so I have two different. I have a loop here going. It says rotate to the 0 position, rotate to the 180 position, and repeat. And so this sends out a command over the Wi-Fi, and it's in the open show control, so this will have all the videos running on it here, and and then it'll have like, okay, for this video, go to the 0 position. I don't know if you can, I'm not watching what I'm doing very well. And then it'll play more videos, and then it'll say, okay, now go to the 180 position. And so that's sort of my show and tell. I've been working all day today to get that running. And so I got I got all that programming going, and so now I'm going to what I'm doing right now is this ESP32, and it has comes up in AP mode, which generates its own Wi-Fi, and it has a web page for control, for configuration of that platform and stuff. And it'll also decode these commands, show commands from the computers to do different things. But what I really need to do is add in a station mode that would hook up to the venue Wi-Fi instead of using my Wi-Fi. And I think I can ask AI to do that, because that's something right up its alley. It's like, okay, I have an AP now, add in a station mode and add in the configuration of it to my web page and stuff. So basically it's like, okay, what is your SSID and the password of the network you're trying to connect to? And it'll go find it and connect to it. So yeah, so that's my next thing, is to add station mode so that I can connect to the venue's Wi-Fi instead of generating a Wi-Fi from the ESP32. So that's my show and tell.
Thanks, Mike.
Mm-hmm.
That's cool. And just an update. So yeah, for barrel racing, Mike clocked in at 43.8 seconds, and then Scott came right behind him at 45 seconds. So
yeah,
it literally beat him by just over a second.
I could have sped it up a little too.
Yeah. Scott tried. He sped his up 10%.
I know. And I said, yeah, for the third try, I should have sped it up one more time. But
good job.
Yep.
Anything's possible, including beating Scott.
Does anyone else have any thing to share?
But Scott still got the 4 corner.
Oh yeah, he did first and second. Oh no, first and third, and you got second. Scott didn't do as good last time though. Last time number 9 nailed it, but this time he got 3/8 of an inch. You have to get under a 1/4 inch to be perfect. So he was 1/8 of an inch off. But yeah, you beat him by 1/8 of an inch. You got 3.125, and he got 3.25.
Ooh.
So yeah,
I was pretty consistent within a 1/4 of an inch, half an inch.
Yeah.
So I probably could have tuned that out a little, but yeah.
It was good. It was good. And then Quick Trip, yeah, he got first and second in Quick Trip, and then David Ackley got 3rd place, which was great.
I know, that was great.
With his little bust on his robot. Ace Ackley.
I think you should at least put like LEDs in the eye sockets or something, make them glow or something,
Yep.
Yeah, I like my little ESP32.
Oh yeah,
I've got a couple of those. They work pretty good.
I quickly became a big fan of ESP32s. They are great little boards.
Yep.
So Ray, you could use an ESP32 board like this and instead of your Omega.
Yep. Is that a S3 or a C3 or
S2?
Oh, S2. Okay. Yeah.
Yeah.
Yeah. Yeah. There's I kind of there's one that's called the Lowland 32.
This is Lowland, but it's S2. But yeah,
Oh, okay. Yeah.
it's a mini. The mini.
Yep. Oh, yeah. So it's got double rows of connections on it.
Yeah, I've only used the outer rows, but yeah,
Yeah. Yeah.
I usually don't use too many pins on this rotating platform. I need to control the motor and measure and read the limit switches. So it's like 3 pins. Yeah.
Yeah. The other one, and I saw Mark use it. It's kind of nice. The Adafruit's Cutie Pie. It's a SAMD 21
Yeah.
based.
I like
part.
those. They're tiny. I like them. Yeah.
Yeah, I think it's like 16 pins, and it has serial, SPI, I2C, analog pins.
Mhm.
It's actually, I think, got a DAC output, but I've never used it.
But for the Wi-Fi, I use the ESP32. So yeah, or otherwise I use the Pico. So
The Pico, yeah. I've got some in a drawer, but haven't played with them. So
I keep falling back to looking at the Pico because of the hardware PIO.
oh yeah. If you have something
It's,
special, you can run it really fast.
Yeah, so for, if you put your encoder routines into PIO, you just forget about them. And they run.
And there's pre-canned encoder routines that run in the PIO. So yeah. So you don't even have to design them, you just get to use the hardware.
Mark posted a couple links.
Yeah, I bookmarked those. That they're useful if you want to know more about ESP32s and the different variations. It's pretty useful. Yeah. First one's just a PDF, but the second one's interactive, like comparison.
Yeah. So especially what's the cheapest, smallest one? Yeah.
They've all gone up in price.
Yeah.
I'm just amazed that they've doubled.
Whoa.
What used to be you could get 2 for whatever, $10 or $12. Now you're finding there's for $30 you can get 3.
Is that the tariff add-on, or?
I don't know if it's a tariff add-on or what, because it's even on AliExpress. It's the same thing when I look at it in Canadian dollars over what I paid a year ago, and they're pretty close to double.
Wow.
So, I used a couple different variants of the ESP32. I used a C6. I run a web radio in my garage. That's the one I zapped, and it shows because it plays a song and then it dies. I have to unplug it, reboot it, it plays again. So I'll rebuild it and see what I can do to add static protection to it. But I just got another one, an ESP32 C3 Mini or C30, little tiny thing.
The wave share.
Yeah.
Pardon me?
The wave share one.
Wave share or knockoff one.
Oh, yeah.
And I'm using that to make a mini blind controller. So to run a little tiny stepper motor and basically control a set of horizontal blinds through Wi-Fi.
Nice.
So to make a $10 Wi-Fi blind controller instead of a $180 Wi-Fi blind controller.
Yeah, there was a guy that came by that had a bunch of, they were like kind of really long and skinny solar panels for mini blinds. And he also had these like, I think they were not nickel metal hydride, lithium iron phosphate batteries. They were like AA size. And so we had the containers for those batteries and all kinds of interconnect, because each thing had like a kind of unique plug on it. So yeah, I don't know if any of that stuff is available in surplus or not, but
So you're talking about a C3 like this one with the
Mhm.
OLED on the front of it.
No OLED on it.
Yeah, I guess you could get those with an OLED on it, right? A small.
Okay.
A little more expensive,
Hmm.
and the OLED is weird. And as far as what Mike was just talking about, making a station versus a AP access on it, I'll type in a link, but go to github.com/poulter/JaredBot/serial relay, and that is the source code that does. That's all this thing does. Comes up, makes itself a Wi-Fi access point. If it can't connect up to a known point, which is stored in the EEPROM, and then it will take whatever serial input and blow it out through a WebSocket connection over a Wi-Fi port. So you get a page up there and the whole works. And all of that code's up there in the JaredBot repo. I'll type in a link here in a second if you're so interested. And of course I did all of this with AI, so it's not like the AI couldn't do it. But it's not, you can't do it, and you don't really need this code. But here's an example of it already working, doing those things. And it actually works pretty good. And in fact, don't store your password if you make your SSID in your source code. Do not do that. Don't store it at all. This thing has a EEPROM on it. So make your Wi-Fi page be able to be configurable, store it in the EEPROM, and then when it boots up, it reads it from the EEPROM, and if it's not there, then become your own access point. Instead of having a static connected up to something. That way, all your passwords, all that's all secure. You don't need to check it in. I don't know how many people actually check in, but I check in everything I got. But just don't. There's no reason to store it there when you can configure it and it's in the EEPROM. And if it's not there, it comes up, gives you an IP address on the OLED here, so you can connect up to it. You know what it is. Pretty cool. And of course, this bot did not compete because we were doing all these other things, so we could try to compete. And yes, it still doesn't balance well on its own. Sad trombone.
Well, thanks, Harold.
You're welcome.
I posted your GitHub, Harold.
What now?
I posted your GitHub on chat.
Okay. I am doing it right now.
I got it.
Oh, you got it already?
Yeah.
And you went and found the JaredBot there?
Yep.
If you go look inside of that repo, there's firmware, there's comms, and there's a serial, I think under serial, I forget all my layout. You look down, there's also a C# application in there that knows how to connect up and then read your serial stuff and start putting it out in this text UI thing I got going on. But it's probably more than you care for at the moment. It's cool. It's got a cool old school black and orange phosphor looking text display when it comes up, and it's just running in a console application. Oh, and by the way, Mark, you did a hell of a job on Saturday. I forgot to tell you that. I'm telling you that.
Thanks.
Yes, thank you.
It was fun. It wore me out, but it was fun.
Yeah. All righty.
For us that joined remotely, it was at times we could not make out any audio.
Yeah, I was worried about that. I need to sit down and come up with a better way to broadcast. Like, I'd love to have multiple microphones that we could switch between and different video streams to switch between. I know there's a lot more complexity to streaming, but I think it would be better for.
Yeah, so we were able to watch the videos, catch the odd comment, but the videos were good. We got to see the robots competing, which was excellent.
But we got to add our own comments, right? Personal soundtracks.
I tried to stay quiet on this one.
I could only hear Paul.
Yeah, he was near. Yeah, it was his phone that he was holding on to, so
Yeah.
he was streaming from his cell phone.
If he was quiet, everything was garbled. The background noise was just garbled.
Man. So we need y'all to sit down and do like a mystery theater 3000 and like narrate the show, and we'll record that and dub it over the video.
We need a commentator that can do that, record it all, and then we can sync it up with the video.
That would be great.
But it was great to watch. It was fantastic.
It was a good event. It was good. It was smaller turnout than last year, but I think Memorial Day kind of like whittled down the crowd a little bit. But it was still a lot of fun. And everyone there had a great time. Thank you, Harold, for the door prizes.
Oh, you're welcome. It's basically it was an unfortunate timing of Memorial Day in our selection, and just unfortunate timing.
Yeah, I think this year I'll try and see if we can avoid Memorial Day weekend for Roboama.
3 years ago, I think they pushed it into June.
Yeah,
I think it was the first Saturday in June. And I think it might have had a bigger turnout.
Yeah.
But 2 years in a row, it's been on Memorial Day.
School is for sure let out by then too, so maybe there's people want to bring their kids or whatever, you know.
No, definitely something to discuss next year. But either way, we had a great time.
And the pizza was good. Thanks, Mark.
Well, that was Paul, but yeah, it was good pizza. I went really fast as well. It was probably good that we had a small turnout. He did not order enough for everybody. Oh, if there was more people, he would have to go get more. But yeah, brothers do a pretty good pizza.
Does anyone else have a robot or related topic to discuss? I guess it's another short night tonight then, guys.
All right.
Yeah, I think so.
Get my station mode running. Yeah.
Yep. Good ammo to get your station mode running, and let us know how it turns out.
Yep.
Thank you, everybody, and thanks for the participants in the competition on the weekend for giving us a description of your strategies.
Yeah.
Okay.
Okay.
All right. Good night.
You guys next week.
All right.
Night, everybody.